So, I'm here today with the title of the talk, The Source of the Sun's Electrical Activity. There seems little doubt that the Sun and other stars do exhibit some electrical activity. However, the source of that electrical activity is much less certain. What I'd like to do today is to briefly review the various models that have been proposed to explain Charles Bruce's observation in 1944 that the Sun's photosphere has the appearance, temperature and spectrum of an electric arc, and discuss those models in the light of modern findings. But we need to start off sometime before Bruce in order to understand the background to his thinking and that of the later modelers. Christian Birkeland seems to have been one of the first scientists to have investigated the possibility of electrical activity on the Sun. Based on observations during his Aurora Polaris expedition of 1902, Birkeland postulated that charged particles coming from the Sun cause the Earth's aurorae. He then attempted to model these effects in a series of Torella experiments, and the results led him to speculate that the Sun itself was charged, and that this was the driver for the particles arriving at the Earth. Finding that discharges from a negatively charged Torella seemed to match the pattern of sunspots, Birkeland wrote, "Sunspots may be considered as the eruptive centres of similar disruptive discharges." And the question then immediately arises, where shall we seek for the positive pole of these discharges, in which the spots, or that which surrounds them, represent the cathode? Birkeland offered three possible answers to his own question, in all cases assuming that the photosphere was the cathode. Possibly the interior of the Sun could be the positive pole, or alternatively the positive pole could be outside it, perhaps in the corona. Or perhaps the Sun might have a negative electric potential of 600 million volts relative to space. But regarding this last possibility, Birkeland added, "It's at present not easy to see how a negative tension should be continually created by the Sun in relation to space." Others were thinking along similar lines. It's well known that a homopolar generator works by rotating a conductor in a magnetic field, which generates an electric field E being the cross product of the velocity and the magnetic field. Also, Hale had shown that there was strong magnetic field in sunspots. This led Wien in 1916 to speculate that electric fields might be generated by motions of solar plasma in sunspots. Hale and Babcock had written in 1915, "We have the strongest of reasons to infer the existence of free electricity in the Sun." They had speculated that high electron mobility allowed light pressure to drive electrons towards the upper levels of the atmosphere, leaving the body of the Sun positive. Unfortunately, other researchers such as Milne, Pannekoek and Roseland showed that the voltage arising from this mechanism was far lower than Birkeland's model required. However, Pannekoek and Roseland in the 1920s did show that gravitational stratification between heavier positive ions and lighter electrons in the Sun's atmosphere would generate a radial electric field of around 150 volts. The electrons would be further out than the positive ions. So this electric field is in the same direction as Birkeland's first model, but opposite to his second and third alternatives. And Nestle-Chan in 2001 recently reminded us of the existence of the Pannekoek-Roseland voltage, writing, "As was discovered in the 1920s, a significant electric field exists in the solar corona as well as in the solar interior. This field is a consequence of the tendency of light electrons to segregate from heavier protons in the solar gravitational field." And this voltage is still recognized today. It forms the starting point for the first generation kinetic models of the acceleration of the solar wind. Jumping forward a couple of decades from the 20s, Bruce was an engineer with the Electrical Research Association who specialised in circuit breaker technology and lightning discharges. In 1941, Bruce and Gold showed that lightning strikes only require a high local field concentration at the negative cloud base, which is sufficient to cause an initial electrical breakdown. Expanding on this concept in 1944, Bruce showed that the tip of the negative leader stroke would then be propagated downwards through regions of much lower electric field, perhaps only 1% of the initial breakdown field, because the strong field at the tip causes further ionization and breakdown locally to the tip. A lightning discharge involves a glow to arc transition in the plasma channel created by the breakdown. Because of the negative characteristic of the plasma IV curve, which you can see here, once an arc has been established, it only requires a small voltage to sustain it compared to the higher voltage in the previous glow discharge regime before the breakdown. By his own later account in 1968, Bruce had come to apply his knowledge of lightning discharges to cosmology. After hearing a lecture in 1941 by Chapman concerning the speed of propagation of solar prominences, Bruce immediately recognized that this matched the speed of a lightning leader stroke, and so he concluded that solar prominences must be lightning flashes. This realization led to Bruce's paper titled A New Approach in Astrophysics and Cosmogony, setting out his thesis in considerable detail, covering everything from the Sun's photosphere to the formation of galaxies. In 1968, Bruce summarized his model as being all cosmic atmospheric phenomena can be explained as deriving from electrical discharges, resulting from the breakdown of electric fields generated by the asymmetrical impacts between dust particles, such as are effective in terrestrial electrical sand and dust storms and in thunderstorms. Note that there are two parts to Bruce's model. Firstly, the electrical discharges which cause the observed spectral phenomena, and secondly, generation of the necessary electric fields by collisions between particles in the extended atmospheres of stars and even galaxies. Bruce recognized that the strongest evidence for his new theory was from the agreement between his arc discharge theory and spectral observations. As befitted the original inspiration for his theory, the agreement was especially good for solar prominences and similar transient events occurring in the corona and chromosphere, such as solar flares. Regarding the visible surface of the Sun, Bruce had written in 1944 that it's not coincidence that the photosphere has the appearance, the temperature and spectrum of an electric arc. It has arc characteristics because it is an electric arc, or a large number of arcs in parallel. More specifically, Bruce suggested that the photospheric granules are transient arc discharges in the nature of sparks on a massive scale. The fact that this photosphere has a definite boundary with a lower density chromosphere could be explained by the fact that arcs cannot propagate through gas densities which are too low to support the current. In deriving the second part of his model, Bruce knew about the emission lines from various positive ions in the solar atmosphere, and about Birkeland's deduction that high-speed positively charged particles enter the F2 layer of Earth's ionosphere. Bruce therefore concluded that the Sun is surrounded by a very extensive atmosphere of positive charge, which he supposed was generated by collisions between dust particles. In fact, this part of Bruce's model does not fare so well. Bruce was unable to offer any real evidence in support of the formation of these extensive atmospheres by triboelectric charging, as the process is now known. His comparison with terrestrial sandstorms and thunderstorms frankly seems wholly inadequate to explain the origin of sustained electric fields on the scale of the solar system or the galaxy. Bruce did not seem to know that stellar atmospheres contain enough electrons to balance out the positive charge of the spectrally identified ions, And they also make the atmospheres highly conductive, which would rapidly neutralize any build-up of triboelectric charge. Therefore, something else must be generating the required electric field. And this is where Ralph Jürgens came in. He was a trained civil engineer and ardent supporter of Velikovsky, who disagreed with the nuclear fusion model of the Sun, which Bruce supported. One of Jürgens' primary objections to that model was the existence of the temperature minimum above the photosphere, which he thought must mean that the Sun cannot be generating its own heat. Jürgens recognized the value of Bruce's theory regarding the spectra of electrical discharges, but wanted him to change his model for the generation of the electric fields. In 1972, Jürgens wrote, "I believe that the Sun behaves as an anode, collecting electric current from its environment, and that the energy it radiates is delivered entirely by way of this postulated electrical discharge. I would urge Bruce to modify his grand scheme to embrace the idea that stellar energy is electrical in origin." Notice what Jürgens did here. Firstly, he reversed Bruce's electric field and made the Sun act as an anode. But more importantly, he proposed that the Sun is powered externally, not by internal nuclear fusion. The Sun, he wrote, is the focus of cosmic electric discharge, the probable source of all its radiant energy. Jürgens proposed that the Sun's potential was 10 billion volts less negative than that of interstellar space. Assuming that the Sun's radiant output of 4 times 10 to the power of 26 watts was generated by Joule heating from the inflowing current, Jürgens could easily calculate that the magnitude of the current must be 10 to the power of 16 amps. But if the Sun is a 10 billion volt anode receiving an electron current of that magnitude, then it would be completely discharged in a fraction of a second and would switch off. Jürgens recognized this problem, so how did he get round it? In 1972, Jürgens suggested that the interstellar potential must keep getting more negative at the same rate as the Sun is discharged, and so the supposed 10 billion volt difference would be maintained. Jürgens was not specific about how this could occur, writing only of a separation of charges on a truly magnificent scale. But remember that all other stars have a similar problem. How could the entire galactic potential be changing fast enough to keep all the stars lit up like electric light bulbs? In 1979, Jürgens was apparently still thinking about this problem. He used Irving Langmuir's work on plasma sheaths in gas discharges to argue that the photosphere is also a plasma sheath formed above the body of the anode Sun. Jürgens suggested that the granulation seen in the photosphere is the same as the anode tufting seen in Langmuir's sheaths. But based on Langmuir's criteria for the stability of these sheaths, Jürgens' model now needed 44 electrons and a proton to flow away from the Sun for every 43 electrons entering it, and that was in order to maintain the charge neutrality in the coronal plasma. How could this happen? Jürgens' answer was unclear. He wrote, "We may be sure that if the Sun found a need to recycle a few hard-won electrons to win some more, it would hasten to do so." He then suggested that perhaps electrons flowed in through the anode tufts and out again through the dark lanes separating the granules. It all seems rather speculative, and it's also not clear that Jürgens fully understood Langmuir's work, which, remember, was based on an external circuit driving the tufting, not an unconnected anode trying to bootstrap the process while maintaining charge neutrality in the surrounding plasma. Perhaps because he was unhappy with this new model, Jürgens then seems to have reverted to his original suggestion. In works edited and published by Earl Milton in 1982, after Jürgens' death, he had written, "I have to postulate continuously increasing electrification in the galactic atmosphere." He also confirmed an implicit assumption of the solar discharge hypothesis is that galactic electrons flow toward the Sun in a stream moving counter to that of the solar protons. The sunward current of electrons that are all important to the present hypothesis might be investigated with a suitably designed space probe. Sadly for Jürgens' model, space probes have now measured the electrons in the solar wind. The measurements confirm that on average the electrons are moving outwards at the same velocity as the protons. So in this diagram, velocity is along the bottom. Most of them you see have an average of 0. The velocity is measured relative to the proton velocity. That is all apart from the strahl electrons in this region here, which are actually moving away from the Sun faster than the other particles. That is opposite to the direction required by the anode Sun model. I presented these findings and many other reasons why Jürgens' anode Sun model was unworkable at the EU conference in 2013 and again at the SAS meeting here in 2014. I haven't time today to go into all the evidence against an externally powered Sun, but I'd just like to refer to some comments made by senior members of the Electric Universe group in response to two of the main criticisms of the model made by myself and others. Firstly, regarding Bridgman's calculation of Jürgens' all-important current, Scott had written that all arguments involving the velocity of electrons are specious. That's very strange, because in physics, a current is directly proportional to the product of the number of electrons and their velocity relative to the ions. However, Thornhill had previously written, clearly, in the immense volume of the heliosphere, an unmeasurably small drift of electrons towards the Sun and ions away from the Sun, brackets the solar wind, can satisfy the electrical power required to light the Sun. But if the drift velocity is unmeasurably small, then the numbers of drifting electrons must be truly enormous. We know for a fact that the density is far too low to make the sums work to power the Sun. Thornhill expanded on his statement in July 2014, saying that the Sun is so complex that measurements are unreliable. Hence, we cannot rely on measurements of the solar wind electron and proton speeds as an indication of the current. Hence, looking for a relative velocity between electrons and protons in the heliosphere is not the right way to approach the problem. Any counterexamples of electron currents flowing away and accelerating with distance from the Sun, varying with the solar cycle, etc., are therefore irrelevant. But remember that electric currents are defined by the relative velocity of electrons and protons. In 2013, Scott tried to argue that the driving current is hidden by huge numbers of electrons, all randomly oscillating in Brownian motion around the ions, with only 1 in 20,000 of them drifting imperceptibly towards the Sun by occasionally jumping from one ion to the next. This is like saying you can power a light bulb by touching it to a length of unconnected copper wire, in which the electron's random thermal motion lights the bulb without any detectable current. It would be very nice to get free electricity, but that's not how things work in practice. The problem is that any electrons randomly reaching the light bulb must be replaced by current-carrying electrons, otherwise the process would stop very quickly. Therefore, there has to be a measurable current down the wire whose magnitude is proportional to the power output. Similarly, in the heliosphere, there has to be a sufficient drift current of jumping electrons passing, say, a virtual sphere at the radius of the Earth's orbit in order to keep powering the Sun. The magnitude of that drift current certainly should be detectable. As we've seen, a very slow drift of all the electrons available at the distance of the Earth's orbit can't carry the current needed because there aren't enough of them. It's even more impossible to power the Sun if only 1 in 20,000 of them are participating. Of course, it doesn't help that Scott and Thornhill often invoke the velocity of the solar wind, in which, apart from the strahl electrons we saw earlier, the electrons and protons are all moving away from the Sun with the same average velocity. But without a relative velocity between the electrons and protons, there's no current at all. The velocity of the charge-neutral solar wind is irrelevant. A second criticism relates to the electric universe's Crookes tube analogy of the heliosphere. I'm sure you're all familiar with this diagram. In a Crookes tube of constant cross-sectional area, the electric flux density remains constant along the tube unless there's a build-up of space charge somewhere. That means that the electric field strength, which is proportional to the flux density, is also constant in the positive column where there is no significant space charge. The electric field, of course, is the same as the voltage gradient shown in the middle graph. But in the spherical geometry of the heliosphere, the electric flux density, and therefore the electric field strength, drop off with the inverse square of the radial distance from the Sun. This means that the electric field can't be constant after all, unless there's a very particular radial distribution of space charge to generate more flux to keep the flux density topped up. Needless to say, there's no evidence of the necessary space charge. Thornhill's answer to queries I raised regarding this problem was that plasma could behave in ways we don't yet understand, and to generate a constant electric field in other ways. Known plasma physics apparently can't explain it. We've seen that Jürgens' model of an externally powered anode sun, driven by a continuously varying galactic potential, cannot work without involving new and unexplained physics of both electric currents and plasma behavior, and denying the validity of contradictory evidence. Judged by any reasonable criteria, the model is dead. But it won't lie down. Jürgens' model is very similar to the one adopted by proponents of the electric universe. Following Jürgens, the EU model has an externally powered anode sun, the photospheric granulation is anode tufting, and the galactic potential does keep changing. The EU group now explain Jürgens' unspecified galactic separation of charges as being due to electrons arriving in our galaxy from another nearby active galactic nucleus, quoting Thornhill 2014. I think it's interesting that Jürgens complained in his posthumously published 1982 papers that Hannes Alfvén didn't support his model. Perhaps that's not surprising. Alfvén had a very different model of the heliospheric circuitry, which didn't involve the photosphere. However, Thornhill has stated that Alfvén's original circuit ignored Bruce's work on the electrical characteristics of the photospheric discharges. It seems we've come full circle back to trying to explain Bruce's observation regarding the photosphere. So let's summarize where we've got to. Based primarily on his identification of solar prominences in the corona as electrical arc discharges, Bruce claimed that the photosphere has the appearance, temperature and spectrum of multiple electrical arc discharges. But no model yet has adequately explained the source of the electric fields needed to drive these supposed discharges. And Jürgens' externally driven electric sun certainly doesn't work. So let's look more closely at Bruce's model and see if there are any other clues. Firstly, here's a reminder of the layers we'll be talking about. The photosphere actually extends a short distance above the visible surface, shown as 0 here. What used to be called the reversing layer is the transparent layer immediately above that, in which the temperature reaches a minimum. The chromosphere is the region in which the temperature starts to rise again, and the transition region between the chromosphere and the corona is where that temperature rise is very rapid indeed. Now, in 1944, Bruce wrote space charges and electric fields are gradually built up above the surface of the photosphere and chromosphere during the solar cycle, until they are sufficient to lead to a sudden discharge or facula. Bruce then referred to his figure 2, which is reproduced on the left here, which shows an eruptive prominence in the corona. But faculae are small bright patches in the photosphere, not enormous loops of material reaching up into the corona. Bruce seems to be mixing up events in the upper atmosphere with those in the photosphere. Similarly, Bruce had written in 1944 that the flash spectrum is emission lines coming from the reversing layer at the very top of the photosphere. But the flash spectrum actually comes from the hotter chromosphere and can only be seen during eclipses when the normally dominant absorption spectrum of the photosphere is hidden. The cooler reversing layer and upper photosphere, which Bruce said was the source of the emission lines, is actually where the Fraunhofer absorption lines are generated. The photospheric spectrum is an absorption spectrum. I'll say that again. The photospheric spectrum is an absorption spectrum, not an arc spectrum. Once again, Bruce seems to have mixed up events in the photosphere and chromosphere. Could this confusion have led him to propose that photospheric granules are arc discharges? I should add that the Electric Universe say that the enigmatic granulation of the visible surface of the Sun can be seen as the billowing tops of the solar tornadoes flecked by ceaseless lightning. This is somewhat different to Bruce's columns of arc discharges, but both hypotheses say that discharges are occurring at the tops of all the granules. So let's look at some modern high-resolution photographs and see what we can make of the evidence which is now available. Granulation is the grainy appearance of the visible surface of the photosphere, thought to be caused by convection currents in the very top of the deep convective layer of the Sun. Granules vary from a few hundred to a couple of thousand kilometers across. The first thing to note is that tops of the granules are not uniformly bright. You can see the difference more clearly in this movie. The very dark patches here are sunspots. Elsewhere there are some hot bright patches, which we'll come back to in another slide, but here and here, for example, you can see there are other areas of cooler, darker granules bubbling up without any obvious lightning at all. It does just look like boiling liquids. In quiet regions, away from sunspots, we can see faculae, or tiny areas of intense white light. So ignore the red and ignore the black, just look for these little dots of white. The dots of white light are known as bright points, imaginative sort of name. Note that these are concentrated into the cooler lanes surrounding the granules. When we look at a magnetic map of the granules, the bright points coincide with small areas of very high magnetic field strength, where the field is thought to have been concentrated by the overturning motion of the granules. But if electric discharges were playing around the tops of the granules, then we should see the strongest magnetic fields there, not in the dark lanes. We must begin to suspect that granules can't be arc discharges. On the other hand, when we look at a sunspot, we can see what do appear to be discharges in the penumbral filaments. So you've got the umbra here, the darkest point, then you've got the penumbral filamented area here, and granulation outside the sunspot. A number of sunspots tend to group together. Now, in this movie, we can see arc leaders progressing along the penumbral filaments towards the central umbra. And that is what Bruce's arcs are supposed to do, except they're apparently diving into the sunspot, not emerging from the lower levels as Bruce thought. Now, clearly, our information is much better than Bruce had in 1944, but that shows that his model was the wrong way around. Also, if you look carefully, you can see that these filaments seem to be located above the granules, as Moore suggested in 1981. The granules visible between the filaments are moving away from the sunspot independently of the filaments. So if you look carefully down here, for example, you can see the granules coming out from underneath the pattern of filaments. In fact, wherever you look, you can see that flow of granules where the filaments are, although they're stretched out, they're not the same position as the granules. And it looks here, another good example, it looks as though the granules are underneath the filaments. As I say, that was proposed back in 1981 by Moore. Now, if the filaments are located above the granules, then the filaments aren't the same thing as the granules. And the granules can't be part of a discharge circuit reaching into the upper atmosphere. They certainly aren't anode tufting driven by an incoming current. Here's another movie showing the same sort of thing. You can see granules underneath the filaments of the photosphere. Quite a number of places, quite clearly. Also, looking at the granules outside the sunspots, watch down here for example, you can see that the brightest areas occur in the intergranular lanes. Another example up here when you watch. You get a concentration of really bright material in the intergranular lanes. And it's almost like froth that's created when material coming from 2 or 3 adjacent granules meets. It's much brighter than even the brightest granule tops, and sometimes occurs between 2 darker granules. This bright magnetic froth is active region faculae, and is possibly an example of lightning-like discharges in the complex magnetic field region between granules. But it's different to the much less bright granule tops, which do look like hot material rising from the surface. When you watch any individual granule, it's what you would expect to see from convection. Also, the contribution from the faculae, the bright froth, to the total solar irradiance is very small. So these facular discharges aren't nearly enough to explain the sun's radiant output. Finally, when we look at a light bridge across a sunspot, we can see that the bridge has a cool core. I hope the definition is good enough on here, but you can just see, hopefully, a dark line down the middle. This is inconsistent with Bruce's arc discharge model, in which the central core is very narrow and is the hottest part of the discharge. But it is more like the electric universe's description of the penumbral filaments, as the electric model views the penumbral filaments as electrical vortices or tornadoes, a slow form of lightning discharge. But we've seen that the penumbral filaments aren't the same thing as granules. So where are the electrical discharges? It seems that they only occur in those areas of very high magnetic field in active regions around sunspots, and in bright points in granular dark lanes in quiet areas of the sun, away from sunspots. But the discharges aren't occurring in the granules themselves. So granules are not arc discharges after all. Bruce's arc discharge theory can explain the spectra of prominences in the corona. It was this observation which prompted Bruce to develop his whole model. However, we've seen that he mixed up these events with faculae in the photosphere, and he also confused the cool photospheric reversing layer with the source of the chromospheric flash spectrum, and he thought that the photosphere displays a line spectrum, not a continuous one. So when Bruce wrote that the photosphere has the appearance, temperature and spectrum of multiple electric arc discharges, it seems that he was again mixing up events in the upper atmosphere, perhaps chromospheric flares, and certainly coronal prominences, with what his model needed to be happening in the photosphere. His observation was incorrect. As we've seen, It's not the photosphere that has these correct characteristics, except perhaps in very limited area of high magnetic field. It's the upper solar atmosphere. And recent images of the photosphere clearly confirm that Bruce's arc discharge model of the photospheric granules is incorrect. Now, it's also worth noticing that Jürgens in 1979 seems to have assumed that the photosphere was highly ionized. The stuff of the granule is the same as that of its surroundings. Both media are largely hydrogen gas ionized to the plasma state. This is incorrect. The 6000 K temperature of the photosphere is not high enough to cause significant ionization of hydrogen, only of the small quantities of heavy metals present in the photosphere as well. So Leenart's, for example, gives the typical degree of ionization of the photosphere as only around 3%, while that in the low chromosphere is up to 50%, the higher chromosphere visible in H-alpha up to 99%, and the corona 100% ionized. So we should expect mostly fluid-like motions in the photosphere to be different to the electrical discharge-like events in the highly ionized upper atmosphere. Discharge activity in the photosphere seems to be confined to those areas of high magnetic field strength where the unipolar generator V cross B effect can generate a significant motional electric field. Although solar scientists don't tend to use the term arc discharge, I must point out that the concept of electric currents in flares and similar phenomena is often discussed in the literature. For example, Foucault and Hinata's 1991 paper on electric fields in the solar atmosphere talks about the electric field component parallel to the magnetic vector, which are predicted by the discharge model of flares, by models of return currents associated with flare particle beams, and by models of neutral sheets associated with two ribbon flares and post-flare loops. Similarly, Ionson in 1982 describes an electric circuit model of stellar coronal loops. And Shimizu et al. In 2009 described the light bridges over the sunspots as current-carrying, highly twisted magnetic flux tubes. These are just a few examples. There are many more in the literature. The concept of electricity in the sun was established in Birkeland's time and is still recognized today by many solar physicists. So to summarize, we've seen how Bruce's observation that the photosphere has the appearance, temperature and spectrum of multiple electric arc discharges led Jürgens to propose that the sun and stars are externally powered. And this principle underlies Scott and Thornhill's electric sun model. We referred briefly to the huge amount of evidence proving that Jürgens' theory of an externally powered sun cannot be correct. But that still left Bruce's observation to be explained. However, we then found that Bruce had made a number of errors in his descriptions of the solar atmosphere and its spectra, which seemed to suggest that he had confused events in the chromosphere and corona with events in the photosphere. He also thought that the chromospheric emission line spectra come from the cool reversing layer. And this confusion led us to wonder whether his interpretation of photospheric granulation as electric arc discharges was correct. When we looked at the granulation in detail, we found that the modern imaging simply doesn't support the idea that granules are arc discharges. Even the EU's reinterpretation of them as lightning playing around the tops of externally driven electrical tornadoes is contradicted by a number of facts. The photosphere displays very little electrical activity, except around sunspots and bright points where the magnetic field is many times greater than average. The discharge activity is nearly all happening in the chromosphere and corona, and it's those regions which are the main source of the discharge-like spectra. So Bruce's model of the photosphere is wrong. Granules aren't arc discharges after all. And Jürgens was doubly wrong to then suggest that they were powered externally. That means that the EU's model of an externally powered anode sun must be abandoned. But perhaps that's not a problem even to EU supporters. Don Scott wrote in 2009, whether or not Jürgens was completely correct in his assertion that the sun is totally or partially powered by external electrical excitation is really not the most important aspect of the electric star hypothesis. What is important is that most of the phenomena we observe on and above the photospheric surface of the sun are explainable in terms of well-known properties of plasma. This is true no matter how the sun gets its power. I agree with Scott here. Jürgens' model of an externally powered sun is neither correct nor necessary. Bruce's observation of discharge-like spectra mainly applies to the upper solar atmosphere, not to the photosphere. But the photosphere does display some plasma-like behavior, despite being only 3% ionized. These plasma phenomena are well recognized in the standard solar model. And many solar physicists also recognize that electric currents are involved in these discharge-like plasma events, although many others don't use this term. The EU group don't seem to realize that there's a heated debate within the astrophysics community about how best to describe this type of plasma activity. For example, Park's 2004 paper, Why Space Physics Needs to Go Beyond the MHD Box, argues against Parker's magnetic description in favor of an electrical explanation of the same observations. So if Scott and the EU group abandoned the anode sun model, they wouldn't be adding anything new. They'd simply be siding with those physicists who prefer to use a current-based model of the electrical activity on the sun rather than a magnetic-based activity. In reality, the source of the electrical activity on the sun seems to be well-known plasma behavior, such as motionally generated electric fields, not Jürgens and the electric universe's anode sun model. Thank you for listening.
I imagine most of the measurements of the solar wind and so on are made on the plane of the solar wind. And very little has been done in the poles of the sun. So I imagine that very little information is actually available as to what's going on the north and south poles of the...
Except I think it was the Ulysses mission, and the diagram I showed with Ulysses mission did get to very high latitudes, about 85 degrees latitude, north and south. And that is the origin of the standard solar wind speed diagram, which did appear on one of the earlier slides. So, no, we do have information outside the ecliptic plane.
And the other place is the Voyager spacecraft, which is now on the peripheral of the helisphere. They've actually measured incoming high-speed electrons.
Yes.
Which presumably do enter into the sun somehow, but not necessarily the way we imagine.
The point is that if you're going to drive the electric sun by an external current, it has to pass the Earth's orbit. And there are simply not enough electrons. The electron density is far too low in combination with the undetectable drift velocity required to explain why we can't see a difference in the velocities. And it doesn't matter what's going on out of the heliosphere, that has got to get past the sun's orbit in order to drive the sun in the electric sun model.
More measurements need to be made on that front.
And the ones we've got don't support the model. This is another fallacy. I look upon it very much as chicken and egg. You can't have a chicken without an egg, and you can't have an egg without a chicken. In the same way, you can't have electric fields without magnetic fields. It's a question of which one you choose to prioritize your description in, and that is what this slide is about. Many people follow Eugene Parker and say that electric fields can't exist and we must use a magnetic field description. Now, I agree. I think he's wrong. I think he's missing the trick, and he's missing a lot of interesting behavior by adopting the magnetic field description. I agree with Parks, for example, whose paper I mentioned, who much prefers the current-based description. But this debate is already out there in the astrophysical community. At the moment, Eugene Parker dominates the field, particularly in America, and his views have got a very wide following, and it's probably fair to say that is the majority view, but there is a significant minority who disagree with that. And I also disagree with it. I support the minority view that you need the current-based description. But this is not an exclusive prerogative of the electric universe model. It's an alternative description which is well recognized in the mainstream and doesn't come attached to the electric star model, which, as I hope I've showed today and also in the EU 2013, the evidence is all against it. The physics is against it.